Okay, on Friday we explored some tools that you can use to look at three-dimensional solids, and I've posted them again on the blog. The interactive 3D shapes for prisms and pyramids, these two tools. You can play around with different, this triangular prism, this rectangular prism. You've got number of faces, vertices, and edges here. You've got nets you can look at. So just as we go through these ideas in today's notes, just realize that while you've got the notes, this note sheet that you've hopefully printed out, and this reference sheet, this geometry reference sheet, you've also got these interactive tools on the website that you can play around with. So if you get stuck, don't forget that that's there. What I want to do now is talk about this definition. So a regular polygon is a polygon that is both equilateral, so all the sides are congruent, and equiangular, all the angles are congruent. And if you look at the geometry reference sheet, all of the regular, or I shouldn't say all of them, but several examples of regular polygons are on one side of that sheet on the right in blue. So you can use that as a reference tonight when you're working on your assignment, and also just as we're going through these ideas in the notes. The first question I want to ask is, do you think a polygon can be equilateral? So do you think that you could have a polygon with all sides the same length, but not all angles the same measurement? Do you think that's possible? Pause and think about that for a second. It is possible to have four equal sides without having, or I shouldn't even say four, I'm talking about quadrilaterals in that case, but you could have equal or congruent sides but not have equal or congruent angles. For example, a rhombus. A rhombus by definition has four congruent sides. So it's definitely equilateral, but it's not equiangular, because this, that looks like to me about maybe 40 degrees. So this angle would be 40 degrees, but these other two angles would be, well, we've got 360 minus 80 is 280, so they have to be 140 each. So it is possible to be equilateral without being equiangular. Do you think it's possible to have a polygon that's equiangular but not equilateral? Pause and think about that for a second. Maybe the easiest example to think of would be a rectangle, because certainly a rectangle is equiangular because all angles are 90-degree angles, they're right angles. But a rectangle that's not a square is not equilateral. Opposite sides are congruent, but all four sides are not congruent. If it was a square, however, then it would be both, and then it would be regular. Okay, and you've got that reference sheet. Don't forget you have that to look at. So think about, is this a regular polygon, yes or no? This is not regular, because while it's equilateral, the angles are not all congruent. Not equiangular. Is this a regular polygon, yes or no? We see it's equilateral, all sides are congruent, and since all angles are 108 and all angles are also congruent, yes, it's equilateral and equiangular, so that's what makes it a regular polygon.